Music Fundamentals, Week 4, Pitch. This is Richard Freemantle. Pitch begins with a discussion of the nature of sound. Sound is air pressure. It is compression and rarefaction of air. If you put your hand in a bathtub and do this, you see waves. And the waves in the water are caused by making thicker piles of water and thinner piles of water. That's the same way that air pressure works. Whenever you move something, you displace air and you put air waves in motion. If there were smoke in the air and you did this, you'd be able to see the waves in the smoke. You can see the air waves of the wind in a flag. But musical instruments move air in very, very tiny vibrations called hertz, vibrations a minute, called hertz, abbreviated Hz. And these waves go into your ear, and there's a little hole there. And the air waves go in there, and inside there's a little tunnel, and inside the tunnel there's this little piece of skin called the eardrum. And the waves beat against the little fine hairs that are on the eardrum. Inside the eardrum, on the other side, inside your head, there are these little bones. And they twist and turn and create electrical signals. And that's what your brain interprets as sound. Now, to reiterate, the two primary elements of music are rhythm and pitch. We just spent a whole lecture on rhythm. Rhythm is action and time. All musical events have a measurable duration in real time. Pitch is the frequency of the sound event measured in hertz, vibrations a second. So these two elements work together to create the illusion which music puts in our imaginations. Now, everybody needs to be able to navigate their way through a piano keyboard. There are groups of 2 black notes and 3 black notes. That's how you find your way. Now, if you look at the little chart, you see middle C right next to a group of 2 black notes, to the left of 2 black notes. That's how you find your way. Every instrument has something that you push or pull or press, like a piano key, a saxophone key, a violin string. The notation is a direct analog between a place on this graph that you see here, these lines and spaces, and something that you do to your instrument. Now, just every instrument has, just like the piano, a name, a letter name for each one of the little things you press or pull or blow. And the name is included in this staff. We have 2 stabs here, one with a little curly Q and one with a little F. The curly Q is called G clef or treble clef, and the lines are every good boy deserves fudge. Remember that. The spaces are FACE. On the bass staff, the lines are good boys do fine always, and the mnemonic for the spaces is all cows eat grass. If you know the name of the note on the staff and the name of the note on your instrument, you put them together and that's how you play. Here is another picture of the so-called grand staff, the bass staff and the treble staff. These are most of the notes that you hear in the orchestra. There are some notes that go lower, some instruments play higher. But you see how they're arranged in line, space, line, space, line, space. That's called diatonic. Now, an interval in music is the same thing as interval in anything else. It's a distance between things. We're going to talk a lot about intervals. Learning intervals, musical intervals, is basic to musicianship. The first interval we look at is the octave. Now, first thing you got to understand is the musical alphabet goes A, B, C, D, E, F, G, and then it starts over, A, B, C, D, E, F, G. There are 8 notes. So the distance between one A and the next A is an octave, 8 notes. 1, 2, 3, 4, 5, 6, 7, and then here's A again. 1, 2, 3, 4, 5, 6, 7, and here's A again. Notice that the octave is a duple division. A440, for instance, is going 440 times a second. The octave below that, 8 notes lower, the next A is 220 hertz a second, or 220 hertz, I should say. An octave below that is 110 hertz. An octave above this is 880 hertz. So you see how the octave has a basic physics component to it. So we've seen that the octave is a very basic component. It's the physics truth of how music vibrates and how it resonates in us. Now, there are smaller intervals in the octave. Dividing the octave into pieces is what intervals is about. And we have this equal tuning temperament system which divides the octave into 12 pieces. These pieces are called half steps. In other cultures, like the Indian culture, there are 18 steps per octave. In other cultures, there are fewer steps per octave. But our basic half step sounds like this. That's a half step. That's as small as they get. So a chromatic scale, so-called chromatic because I use the black and white keys. Don't ask me why it's called colored. But anyway, we go. And the last, back to the next octave, sounds like this. So let's take a look at how that looks in notation. Now this word diatonic, the scale we looked at a minute ago, was all step by step on the lines and spaces. Now you notice that this scale has these little funny symbols in front of it, the little hash mark, which is a sharp. The sharp stands for a half step higher. So for instance, this note C, a half step higher is not D, it's C sharp. Now there are places in the diatonic scale in this key of C, that are natural half steps. Between E and F and B and C are natural half steps. All the other notes have a black note between them. And these black notes can be notated as either sharps or, as we'll see in the next frame, as flats. Now here we see the same scale written with different accidentals. These sharps and flats are called accidentals. The hash mark is a sharp, the little B is a flat. Sharp means a half step higher, B means a half step lower. If you look at the top scale, it goes C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, B, C. If you look at the bottom notation, it's exactly the same notes, this time written in flats. C, D flat, D, E flat, F, E, G flat, G, A flat, A, B flat, B natural, C. Now the idea that this black key can be C sharp or D flat is the idea of enharmonic equivalence. It means that this notation, C sharp or D flat, is the same key. A much larger concept here is the subject of internalization. One of the reasons you have met gamut in this class is because you must learn how to internalize these intervals. Now you're going to learn a whole bunch of intervals. You're going to learn half steps and whole steps and minor thirds and major thirds and fourths and so on. All kinds of different intervals. And a musician is able to hear those things in his, her head. So we're going to keep coming back to this, because if I'm not teaching you how to internalize this music, then there will always be a block between you and the paper. The thing of notation is such a great invention, but there are many, many musicians who don't really get how it works. The notation is supposed to create an imaginative reality in your head, which you then transform into real sounds on your instrument. But without the imagination first, you're pretty helpless. I mean, you could be a computer and just push the right key at the right time, but it wouldn't be music. It has to be an imaginative internal reality first. And like I say, we'll come back to this many times. This is a list. You have to know this. You can't compute the quality of intervals. You can't figure out what a triad is. You can't figure out chords. You can't figure out anything without knowing the number of half steps in every interval. It's like knowing your sums. 2 times 2 is 4 is very basic to math. A minor second is 1 half step. A major second is 2 half steps. That's basic to music notation.